Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in the previous three videos, I've been discussing the operations of arithmetic and indeterminate forms, so-called indeterminate forms. They're actually nonsense. There's no such thing as an indeterminate form. It's just nonsense. Also, I've been showing you that 0 is not a number and it cannot be considered to be a number despite its extreme usefulness in mathematics. It's not a number. So, how do we get the operations of arithmetic? Well, we get them from geometry, okay? We get them from the circle. So, for example, if we have a circle like this, we can define all the operations. We can define a difference by taking the smaller length and comparing it with a bigger length, and then this section here is the difference, right? This section. Now, similarly, if we wanted to take the sum of these, we would put the divider on these ends, wouldn't we? Like that. All right. So those two operations are very easy and they work with any number in any magnitude. Similarly, if we wanted to multiply these two magnitudes, we'll notice that always this red line segment is the product. If we wanted to take the quotient of this line segment with either of these line segments, so example, with this line segment, then the quotient is 3. And if we're dividing by this one, then the quotient is 2, right? And this line segment here acts as a unit. What this means is that if we had a unit of 2, then this line segment here is actually 1 because it's 2 divided by the unit, right? And this line segment here is 1.5, and this one here is 1.5. Okay, let's just change it around a little bit like that and do that. Okay, so in this case here, this is 1.5, this is 2, and this is 3. So 1.5 times 2 gives you 3, right? 3. It's this segment here, 6 divided by 2. So you could choose any of the line segments as a unit, and you'll always get the correct result. Now, why can you not have 0 as a line segment? Let's see. So, let's make that 1 again. Nice, easy unit to remember. So, you can't have 0 because if this is 0, then you don't have any of the other line segments any longer. Okay, so basically what you're saying is that the blue times the magenta doesn't exist. There is no such line segment, okay? And if you wanted to do the same 0 times 0, then that's absolute garbage, as you can see. There's no number that is represented by 0 times 0, okay? And similarly, you cannot have a unit which is 0. That means if we move this up here and this up here, then we have nothing, right? Do you see that? So 0 is not a number. It does not act like a number. It pretends to be a number. And what I've done is today I've actually written a very beautiful article for you explaining what these arithmetic operations are. They're actually measures, okay? And I tell you what each of these things does and how it relates also to the geometric concept. And I'll also get Claude which is an AI, to produce its 2 cents, which you see in the red font. And then at the end, I summarize. So I say how the operators are all intertwined, ordered in terms of importance, and realized incrementally, starting with the most primitive being that of difference. So we start off with difference, then we get sum, then we get quotient and product. And I do yet another summary after I define number in the only way it can be defined. A number is a name given to a measure that describes a ratio of magnitudes. Okay, that's actually magnitudes, not magnitude. Then, in summary, subtraction produces a number that is required to complete a measure, right? Addition produces a number that is a complete measure in terms of the addends, those line segments being added. Division produces a number that is a complete measure using subtraction and or addition, whereby dividend is measured by a divisor and or equal parts of a divisor. Finally, multiplication produces a number that is a complete measure using division, whereby a dividend is measured by a reciprocal divisor and or equal parts of a reciprocal divisor. Right? So those are the summary of the four operations, and I place a link here which you can access another very interesting article that describes the symmetry of the circle and how it produces the four basic operations of arithmetic. They're not defined, by the way. Humans didn't invent those. They exist whether humans ever existed or whether God or the gods existed, or even if nothing exists, these operations exist as well from concepts. You don't get to define them. You cannot define the four basic operations of arithmetic. But what I have done is that I've done what nobody else could do and defined them using these immutable facts and properties of the circle, okay? Because these operations all come to us from the circle, and it's very important because it avoids all these pitfalls that you find in algebra, things like indeterminate values and things like division by zero, crap like that, and basically it gives you a very deep conceptual understanding that is so important and imperative in becoming good at what you do in any of one of the STEM disciplines that you might be following. Because at the end of the day, mathematics is the abstract science of measure and number. And you can't dispute or refute that. That's what it is. It has nothing to do with the anti-mathematical crap of set theory or axioms or anything like that. And on my channel, you will find lots of videos that talk about that. And also, if you follow me on academia on this site, you will see that I have plenty of articles that you can read and study, over 253 papers, one book, etc. And I have lots of followers, 500 of them. Okay, 500, just about 500, one short. And I do know better than anybody else. I know that sounds arrogant. It's not. It's just a fact. I'm not saying that as if, it means anything great, because I discovered these things. I didn't actually invent them. They've always been there. It's just that it takes genius to realize these facts, and you won't appreciate what I'm telling you unless you actually study these things. Okay, so you have to study these things. I'll place links to everything in the details section, and if you're not already a subscriber, become one. Click like. It's important that you click like. Whether you like me or not, that doesn't matter. You want to preserve this knowledge, this precious knowledge, for the rest of humanity. Like Dave Farina, I'm also rooting for humanity, believe it or not. Ultimately, I hope that humanity succeeds, even though right now I'm not very optimistic. So that's pretty much it. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.